Video, we're going to do some basic stoichiometry. Instead of using grams this time, we're going to use liters. Because sometimes when you're describing like a gas, it's not always easy to weigh it out on a scale, but we can measure the volume. Now at first we're only going to do it under one simple condition, and that's at STP, where 1 mole of any gas occupies 22.4 liters. Every time. Doesn't matter what gas it is. If it's hydrogen, helium, nitrogen, argon, it doesn't matter. 1 mole of any gas occupies the same amount of space, same given set of conditions, and at STP, which is 1 atmosphere of pressure and 0 Celsius, that is 22.4 liters. So it's a good reference point, and it's really an easy addition to our map of Mole Town. So if we take a look at our map of Mole Town, we can see that no matter what, we always have to figure out how many moles of one thing we have to figure out how many moles of something else we can make, or how many moles of something else we need. So far, we've only been using grams to get to that point, because we can measure that. So for solids and liquids, that's a viable way of measuring things. You know, grams, you convert to moles by dividing by the molar mass. But if we're talking about gases, well, now we're just going to have to use this as a conversion factor. So if you have the volume of a gas, you divide it by 22.4 liters, that's how many liters are in 1 mole, and that gets you to moles. Or, if you know how many moles of a material you have, and you want to figure how much space that's going to take up as a gas, you then would multiply by 22.4, because that's how many liters are in a mole. So up here I just put a sample problem where we have the combustion of propane, where you reacted with oxygen to produce carbon dioxide and water. And this is the molar ratio in which these things react. The question I ask is, how many liters of carbon dioxide, which is a gas, can be made from 88 grams of compressed propane? Let's pretend it's a liquid that we measured to be 88 grams. So just like before, I started you off in grams. So on our map of Mole Town, our only way we're going to go from that is to figure out how many moles of that propane we have, which we do here. We divide by the molar mass, which is 44 grams per mole, to find that we have 2 moles of propane. Then the next step is to figure out how many moles of carbon dioxide we can make, because that's the substance we want to know about. Comparing the two things, we use the ratio from the balanced chemical equation to say we get 3 moles of carbon dioxide produced for every 1 mole of propane burned. So that means we would make, from that amount of propane, 6 moles of carbon dioxide. Now, instead of figuring out how many grams that would be this time, now I'm just asking you how many liters that's going to take up. So we're assuming it's at STP, and we'll learn more about what that means in the next unit. But for now, you just say, okay, if I have 6 moles of gas, every mole of gas takes up 22.4 liters. That means we'd take up we would have produced 134 liters of CO2. To sig figs, I realize it would be 130, but whatever. So basically all I've done is given you another thing you can figure out from the amount of moles you have, or another way to get to moles if you have a gas system.